Hi everyone! For those of you who don't know me, I'm Miss Hu, your physics teacher. Now, if you're looking at this video lesson with the lesson objectives and you're wondering, wait a minute, isn't this a chemistry topic? And you're wondering, what is Miss Ho, a physics teacher, doing creating a video lesson on chemistry? Well, if you know your sciences, and I hope you do, you should of course be aware that there is a lot of overlap when it comes to these two sciences of chemistry and physics. So I decided to create this video lesson for the benefit of students who may find it useful to learn a little bit more about the atomic structure, especially when it comes to drawing the electronic configuration. Now, this particular video lesson is suitable for students who are taking Key Stage 3, Key Stage 4, and SPM as well, and any other syllabus that covers the electronic configuration up to atoms of elements of proton number 20 within the periodic table. So, without further ado, let's begin. First things first, we are going to review the concept of what are the subatomic particles that exist inside the atom. I'm going to move my face out of the way first because it's getting in the way of the toolbar. And now, according to the syllabus, you should have learned only three subatomic particles. Three. Now, if you haven't learned it, never mind, then take this as a very quick lesson. So, subatomic particles that you learn, what are they? Come recall. That's right. Assuming you answered correctly, there are neutrons, protons, and electrons. You have to also know the positions of the neutrons, protons, and electrons within the atom. So, starting first with the neutron. Now, neutrons, like the protons, exist inside the nucleus of an atom. So the neutrons are the neutral particles. That means they don't carry charges like the other two. And proton carries positive charges. Electrons carry negative charges. So I'm putting the colors here because I'm going to just label um, and draw some small particles here just to represent these subatomic particles. So as we already have learned, as you should have, okay, that neutrons and protons, let me copy paste. Oops, just going to put a few randomly around here. Okay. Okay, so we've got, let's say, a few neutrons, and we're going to put a few protons as well. So I'm just going to color code them just for easy reference. Okay, the neutrons and protons all lie within the center of the atom, which we will call the nucleus. I'm just going to also draw this really quickly. So these are the neutrons, and just going to label this way. These are the protons, and of course we've got the electrons, which for now, I'll just put them as green blobs. One, it's not moving. Okay, so these are the electrons. And yes, the neutrons and protons both reside in the center of the atom, which is known as the nucleus. So I'm going to label that nucleus, and we're going to label, of course, the nucleus accordingly. And the electrons, on the other hand, orbit the nucleus in these black rings, and these rings are known as shells. Okay, probably shouldn't cross the line. Let me move the electrons to a better location. Come, come, like so. Okay, we're going to put it like this, and here are the electrons. Right. So yes, there could be there are probably more electrons over here. So I'm just going to move them to the next ring. Okay. If it moves, come on, it's not moving, it's just rotating. It's just annoying me right now. Okay. And we will just place them. Is it? Okay. So if you're wondering, okay, all right, why are there like so many rings? Is there a set number of rings? Could I just be one ring or two rings? Well, we shouldn't call them rings. They're actually called shells. I'm just going to label that for you as well. So we're going to call these shells. Just put it in the appropriate color so that it's an easy label. Yeah, so why is there like one ring or what did I say? Did I use the word ring again? Okay, why is there one shell or two shells or three shells? Well, that's what we're going to be learning in drawing the electronic configuration. So this is just a review of the subatomic particles that exist in an atom. Now let's go into drawing the electronic configuration. So now on this slide, what we have over here, I've just drawn only the nucleus and the first shell. So we're not going to bother with the protons and neutrons inside the nucleus when we're drawing the electronic configuration, because we want to just see how the electrons are arranged when it comes to the atom. So don't bother about the neutrons and protons, we'll only draw the electrons. Now, when we draw the electrons, normally we don't draw them as circles, we draw them as an X, as a cross. So I'm going to mark an X like this for the electron. Now, before we go into that, first things first, you need to know the rules when it comes to drawing the electrons. Okay, first of all, you need to know how many electrons there are within that particular particle. So for example, if we're looking at an atom and you see, okay, this atom has one electron, then you need to draw only one electron. If it has like 10 electrons, then you have to plan, or rather you have to figure out, okay, how are the electrons arranged? So here's the rule. Now, when it comes to the first shell, the maximum number of electrons the first shell can hold is 2. So if we look at the periodic table, for example, and we start with the hydrogen atom. So the hydrogen atom only has one electron, right? So you only draw one. So we'll mark an X here. That's one electron. Then when you go on to the next atom, which is helium, helium has two electrons. Now, remember, the first shell can only take up to 2 electrons. So if you see, hey, helium has 2, yep, that is the maximum the first shell can take, right? So you draw 2 electrons in the first shell. Now, the proper way to draw this is to draw the electrons opposite each other. That means not side by side and not random. The electron arrangement within the shells are also not random. There's a certain order you have to follow. So if you've drawn one electron on one part of the shell, the other electron should be directly opposite the other. Now, does it have to be up, down? No, you can even draw it left and right, or you can draw it, in a diagonal if you like. But the 2 electrons must be opposite each other. So that's the first shell. Now, when you get to the second shell, though, it's like, how do we get to the second shell? Let's look at the next element, say in the periodic table. Say, for example, we're looking at the element with proton number 3, like lithium. Now, lithium has 3 electrons, 3, right? But we already established a rule that the first shell can only have maximum of 2. So if you want to draw the third electron, you cannot just, okay, I'll squeeze one electron into the first shell. No, cannot. Because the first shell maximum is only 2, which means that now that we have 2 electrons in the first shell, there's one more electron that we need to put in, right? That needs to go into the second shell. So now we've got a second shell. Okay, you need to add that one more electron into the second shell. So this is where we can place the next electron. So the second shell maximum can take up to 8. Can you see? 4 and 4. Oops. 4 and 4, 8. Okay. Up to 8 electrons. So that means what you do is, if you see that the element, or rather the atom, has up to maybe, okay, let's say for example, this particular atom has 7 electrons. So 7, right? So the first 2 must go in the first shell. And then what's the balance? 7 minus 2 is 5, correct? So the 5 electrons now go into the second shell. Remember that the way we draw the electrons is not random. You can't just, okay, 5, all right, I'll put the 5 side by side here, teacher, ta-da. Cannot. You cannot randomly draw electrons anywhere along the shells. There's a certain arrangement that you must follow. What you can do is you can imagine that we divide the shell into quadrants. Whoops, I was trying to draw quadrants. Quadrants like this. And what you do is you need to fill up each quadrant first. So let's say I said, right, we have five more, right? So out of seven electrons, two have been placed in the first shell, so five more in the second shell. That means you've got one here. Now the second one must go directly opposite first. So this is where the second electron on the second electron on the second shell goes. Then the third one goes into the next quadrant. Now you can go on the left quadrant or the right quadrant first, it doesn't matter. So I'm going to put on the left quadrant because, why not? So you got one, two, three, the fourth one, opposite. And we have one more, correct? So once you have already filled up four, when you want to go into the next four, then this goes in pairs. So you got your one, two, three, four. The fifth one goes in a pair side by side next to one of the electrons here. And that's seven. So if let's say this particular atom has, say, 10 electrons, then what you do is when you fill up, you've got your one, two in the first one, eight more in the next shell, right? So you'll have to go one, two, three, four, and then the next four you fill up following the same rule of going five and then over here six. Okay, opposite first, and then fill up the next quadrant side by side, seven, and then eight. So this is how you fill up the second shell. If you have an atom that has more than 10 electrons now, like let's say, for example, it has 15 electrons, 15, 1, 5. So if you got 15, so now you have, okay, you've got two in the first shell and you've got eight in the second shell. That's a total of 10. There's five more to go, right? So that goes in the third shell. So in the third shell, you follow the same rule. Now the third shell is similar to the second shell in the sense that its maximum number of electrons is also 8. And you follow that rule of going opposite first and then filling up the quadrants. So like I said, let's say this is 15, right? So we've got 2 in the first shell, 8 in the second shell, leaving us with 5 for the third shell. So you'd go one opposite, the other. So that's 1, 2. Then fill up the quadrants. 3, and then 4. And once each quadrant has been filled up, then the next 4 repeat from the beginning again, side by side this time, just like you did with the second shell. So you're starting to see the pattern, right? Okay, so this is true for all atoms of elements up to proton number 20. If it's more than 20, that means 21 onwards, that's a different set of rules that it kind of follows, and that's not covered in this video. So don't worry about that. You just need to learn how to draw this electronic configuration only for up to 20 protons. That means 20 protons here, meaning that up to 20 electrons. So if you have up to 20 electrons now, right? How do you write it out? So you have 2 in the first shell, 8 in the second shell, and then you'd fill up the next 8 in the third shell. So 2 and 8 gives us 18. Then you've got 2 more, right? Whoops, that's a terrible looking X. That means the remaining 2 will now go into the fourth shell. And just like for the other shells, the electrons must be opposite one another. And that's how you draw the electronic configuration for atoms of elements up to proton number 20. Now, in addition to this, of course, you should know how to write out the numbers, which was something that I should have covered along the way. But you know what? I'll do it right now. So let's say you have an element for an atom. Sorry, if you have let's say the electronic configuration for atoms with, let's say, a proton number, or rather not proton number, let's look at, let's say, 4 electrons. So if this atom has only 4 electrons, that means the first shell would have 2 and the second shell would have 2. How you write it is 2, 2. So some syllabus use comma, some syllabus use the period symbol. Depending on which syllabus you use, of course, follow the one that your syllabus uses. But sometimes, like I said, sometimes not sometimes. Um, Actually, both are accepted. It can be comma 2 comma 2, or it could be 2.2. So in my case, I'm going to use comma. If let's say there were what I call 7 electrons, see, then it would be 2 5. Let's say there are 15 electrons. Oops. Then you would write the arrangement as 3 shells, right? Because it would be 2 8 5. If there were 20 electrons, then it would be 2 8 8 2. And if you're wondering, but teacher, what if there's only, like, 1 or 2 electrons? Then yeah, let me put that at the top here. If it's only 1 electron, then the arrangement is just, well, 1. There's no comma because it's only 1 shell, right? And same thing for 2 electrons as well, this be the 2. So this is how you write the electronic configuration, and this is how you draw the electronic configuration in all these different shells. So the thing that you should be doing now is to practice drawing these configurations out. Oh, before I forget, and I forgot to mention this at the beginning of the video, every time you draw, and if you had to draw the circles manually if it was not provided in the paper, always have one circle first. The middle circle is the nucleus. Now, I put a color here just to differentiate it, but obviously if we're drawing this, with pencil, don't use pen when you draw, pencil. Yeah, then it'll just be basically like this. So the first circle in the middle is the nucleus. So you must have one circle first to indicate this is the nucleus, and then the second circle will be the first shell, and then so on and so forth. So this is how you should be drawing the atom and the electronic configuration if you require it to do so. So I hope you found this video helpful and educational. Please don't forget to click like and subscribe for more science videos by Miss Ho.